Okay. Hello, everybody. I can't see anything at all. There's just lights in my face, but that's fine. Hopefully this is okay. Hello, thank you for having me. My name is Glen. This is my face. That is my Twitter handle. That's my GitHub. I'm here to talk to you about serverless computing. I live in London for about 4 more weeks, and then I move back home to Australia. So it's really nice to be able to come to a European conference without having to fly for 24 hours to get here. So thank you for that. Let me just set my timer so I have something to look at. I work at Cloudflare on the workers team, specifically on the D1 project, which is our new database, which I'll talk about a little bit at the end. It's pretty early, but it is kind of exciting, something new for me to work on. But as was mentioned, you may know some of the projects I worked on previously. I was co-creator of CSS modules. I wrote not the stuff that was the bugs in the last talk, by the way. I wrote the good stuff that doesn't break. But I also created style components, which has been quite successful in the React community. Both of these are CSS and JavaScript technologies that you may have used, you might like, you may hate. That's fine. All of those are fine. But the reason I bring it up is that it's kind of a strange shift to be previously working in CSS and JavaScript and now up here talking about serverless computing. It is a little bit strange. I have had to learn quite a lot in my new role. But putting this talk together, I kind of noticed that there is some similarities between what was happening a few years ago when that early CSS and JavaScript kind of shift was happening and what's happening now with serverless computing, which is this idea that you get these new capabilities long before they get wrapped up in good solutions, right? So the capability for CSS and JavaScript was the idea that Webpack could compile a CSS file and inject some code into a JavaScript bundle. Previously, like Sass and PostCSS, they just compile CSS to CSS, right? Or their language just to CSS. So crossing that language barrier was this new capability. CSS modules was like, well, maybe you could use it for isolated styles. Style components, using the React component model and template strings, both of which we didn't invent, but we just sort of packaged up and tried to build a solution around. And to my mind, that's a really exciting place to be experimenting in. There's tons of stuff to build. You don't necessarily have to build the next React, but you can build something on the side of it that actually solves a real problem. These new capabilities kind of come first. And for a while there's lots of competing ideas. None of them are very good, and then gradually, you get something that works well. But the main body of my talk is going to be, well, it's the history and future of cloud computing, which is the dullest possible thing to talk about, which is why I didn't call the talk that. I called it Beyond Serverless, which sounds a lot better, right? But basically, I'm going to be talking about this general arc of what cloud computing is doing. Because unless you're an expert or you're really kind of interested in this sort of stuff, it just seems like there's new dumb cloud stuff happening all the time, and everybody's telling you this is way better, that's way better, you can't use that, you got to use this. But what I want to kind of convey is that there is a general trend. Things are getting better, and they are getting better in a specific way, and I think if you project it out, the future is quite optimistic, particularly if you're somebody who cares more about users, maybe isn't a back-end expert, and wants to build full-stack apps. So I'll talk about the past and how we got here, then I'll talk about where we are right now, what I would consider the best possible current architecture for building a big app, right? And also how it kind of sucks, because it does kind of suck, right? And it's very easy for me to come up here. I'm employed by somebody who makes a platform, and I can just come up here and say, hey, it's going to solve all your problems. But realistically, it's much more interesting to say, of all the people who are really embracing this new stuff, where does it still break down? Because that's much more illuminating about how far we are along this path and whether it's something you want to join and start doing. But what I really want to talk about is stuff that may never exist, stuff that really could be really very cool, right? But I need to lay some groundwork first, so let's start. I'm going to try and boil this down because I don't expect people to be experts in the room, but I also recognize that some people will know this stuff, so we will go quickly. So I'm going to give a very abridged version of the history of cloud computing. And basically, the cloud is just other people's computers, right? That is the famous joke that there is no cloud, it's just other people's computers. And actually, for a while, that's pretty true, because well, show my age here a little bit, but the first time I was doing full stack apps, I was using Rails on a single server and deploying them to Heroku. And I kind of knew that there were these pieces other than Rails in there. I knew that there was a database, and I understand that I could install cache and some background jobs and stuff. But really, it was just like a single server was the unit that I was working with, and I was hacking on the Rails part. So I didn't understand it, but I felt very productive, and Heroku gave me a great place to just deploy it and be happy, right? And the first version of the cloud is effectively the same model, except now you just have servers for each of those services or those processes. Maybe you have multiple because, most of the work is happening in the app server layer in Rails, so you have several of those servers. You only have one database, you only have one load balancer. This is where the idea of the cloud is just other people's computers is great, because I don't want to buy all these computers. I just want to rent them, right? And if I have a small app, I'd maybe fit them on small machines, and as I grow, they could get bigger. But really, I'm doing the exact same thing I was doing before. The modern cloud kind of looks similar, but it also kind of looks different, which is that every one of those pieces has now been replaced with a branded, hyper-specialized thing that you have to learn and read all the documentation for and specify how it connects to each piece, and you can't port from one cloud to another, but technically is better than what you were doing before. So modern cloud deployments look a lot more bespoke than just other people's computers. The point I want to make is that for the first kind of chapter of the cloud, the architecture didn't change. It's not all that easy to see, but the architecture didn't really shift, right? We're still working with the same building blocks. And that had a major problem, which is that the interconnectivity of all these pieces is really difficult. It's hard to model everything you need to do if all you have is servers. I'll give you an example. All right, let's say someone asks you, hey, when this trigger happens, you need to go and send a bunch of emails. So you go and get the emails from a database, but you also need to go to the spam API to make sure that those people haven't flagged you for spam, because if you get another strike, then you're going to get blacklisted from Google emails or something like that, right? So there's some complexity. Then you want to send off the emails to the email API, but you're not on the pro plan, so you have to queue them up and do them one at a time on background job, right? There isn't a very good home for logic like that in the traditional kind of architecture, and there's tons of little pieces that need to work like that. You can't run a server for each of them because that would be way too expensive, and you can't run one big server for all of them because half the time none of them are running, and then sometimes when you have to do a ton of stuff, all of them might be running. And so you have really difficult to predict load, which is why serverless came around, right? Serverless says, add another layer into your application. These are just pieces of functions. Now, if you haven't really used serverless before, I'll show some examples in the future, but effectively you can think of them as tiny pieces of computation without a container. So they're just functions as a service. They sit in between these things and they can encapsulate things. And once you start to use them, you end up rolling them out everywhere that you might have dynamic load, because by definition, they can spring in and out of existence as you need to. And so they're perfect to replace your app server. In fact, Next.js popularized this a lot. Every route in your page became its own serverless function on Lambda. I don't need you to understand it necessarily, but the point I'm trying to make is that this is new. This is the first genuinely different hosting model than what came before. There is no pre-cloud version of serverless, right? It relied on thousands of companies deploying on massive data centers with all this extra capacity to be able to offer the idea that you could just put a function in the cloud and it would just run. You can't really do it yourself, right? The other really profound change is that it scales to zero, right? If you're not running it, it doesn't cost you anything. You can have hundreds or thousands of functions that are just not running and just not costing you anything, right? Which means when you deploy a new version of one, it can just be a new function. The old one can stay there, it just stops getting traffic and stops charging you money. Changes the way you think about deploying, it changes the way you think about rolling back, about how you do migrations and how you could roll out gradually. All of this stuff kind of builds on top of this thing. But for the audience in the room, and for me, the thing I'm more interested about serverless is that you have to know less about the infrastructure to contribute, right? So more people can contribute to what was traditionally an infrastructure problem. Like this is the original Lambda syntax, which looks a little dated now because it's callbacks and it's Node and it's CommonJS. But this is just JavaScript and it runs in the cloud. It's magical, right? Cloudflare Workers, similar thing. It now uses the fetch API, but again, all you need to know is how to write JavaScript and how to publish it, right? Using whatever tool. And that's a big change because it kind of democratizes across an organization who can write back-end code. But there's still another problem, which is unless you're working on something very geographically specific, your user's going to be all over the place, and everything we've been doing until now just runs in one place, right? In fact, a lot of these cloud services can only be interconnected if they're running in the same availability zone, which is a subset of a region. It's very difficult to break out of that and have more than one, right? In fact, the only place that I've seen it really be worthwhile is for redundancy. So if all of Amazon goes down, you've got a backup on Google Cloud, right? Some people will invest the time to make that work, and there's tools that do make that better. But it's never really been worth it to do for performance, right? To get closer to your users. Until edge compute came on. This is chapter 3 of the history of cloud computing. Because in that diagram before, there's actually tons of other servers around, right? The majority of bytes that are flowing across the internet are not coming from somebody's application all the way across the world to somebody's desktop or mobile phone. They're cached and delivered locally from these things called content delivery networks, CDNs. What that effectively is just a worldwide network of computers that all keep a copy of the information that you need. And Jamstack and static site generators explicitly target this. They're like, if you can make your app 100% static, then you can just ship it to all of this existing infrastructure, and it works brilliantly if you can make your app static. Edge compute basically says, well, rather than trying to make it static, why don't we just make those CDN nodes mini clouds, right? Technically, virtually impossible, incredibly difficult, completely changes what you need to do. These things that were just serving content now need to be running applications for tens or hundreds or thousands of concurrent applications. And as a result, the innovation, this sort of stuff came out of CDN companies, not out of traditional clouds. These are companies like Cloudflare that had massive amounts of servers, huge amounts of CPU, and we're like, well, maybe we can figure out a way that you can run your app there. And I'm not just talking about a few servers. It's not just 1 to a dozen. I think we just crossed 300, but maybe we haven't yet. Anyway, it's about 300. This image is from a blog post last year saying we just crossed 250. I know we've got more than that now. And that's a very different mental model to be like, okay, I'm deploying to 250 or 300 places worldwide. But to put that in perspective of what your users care about, we're talking at 95%. This is now a Cloudflare's network. There are other networks with edge computing. I don't want this to be 100% about Cloudflare. It's just that's where I work, that's what I know. But 95% of the internet connected world is within 50 milliseconds, and 80% is within 20 milliseconds. It takes about 200 milliseconds to blink. So you can go round trip for 80% of the internet connected world 10 times between a server and a laptop in the time it takes to blink. Suddenly, it makes so much sense to try and do as much as you can near the edge, because it's no longer just a matter of scaling these applications anymore. This is just better user experience, right? Faster is better. You can do more work. Which is why, right now, one of the biggest areas of innovation in the JavaScript world is these edge rendering or edge-first JavaScript frameworks. I was going to say at this slide that I can't go into this because it's a whole talk in itself. Turns out there's actually 3 talks at this conference about 3 of these. So Remix tomorrow, Quick this afternoon, Svelte this afternoon as well. Right? These are huge shifts, and they're saying basically you can write more of your application designed to be running at the edge rather than running in some server. And it's taken a few years to come, and there's plenty of work still to be done. But that progress has started. Again, the point I want to make is that this is all really new. So there's going to be areas where it doesn't work as well as what you're used to, which is also an opportunity to build something new. So for someone like me, it's just catnip, whatever catnip is for humans, probably some kind of drug. But like a good drug for work. But it's this idea that you can actually build something to make these new capabilities into solutions for people. So that's where we are at the moment, right? What I'm calling the state of the art. That there's a fundamental tension between having your users all over the globe, but you can't put your infrastructure there. So the solution is keep using the cloud, your centralized core infrastructure. Use as much serverless as you can because it's easier for people to contribute to and can be easier to maintain. And then use the edge as much as you can because it's much better for the users when you do. To put that in our diagram from before, now there's a full difference between our edge functions running all over the world, talking over APIs to our old kind of core, our original centralized core. And actually, this is great. You can just sprinkle in a little bit of edge stuff to do one little thing, and then gradually you'll get more and more, you'll find yourself finding more and more reasons to put code to the edge. But it has problems once you really embrace this stuff. The first is that now you really do have to admit that this is multi-cloud, right? All of the good edge networks are coming out of CDN companies, but all your traditional cloud infrastructure is going to be running on Amazon, Google, Microsoft, or others. So now you have to, as an organization, figure out how do I have my app in two places? And that's more difficult. The other thing is that serverless still kind of sucks sometimes, right? There's still stuff about serverless that's harder than just, hey, a server runs some code. Things like, depending on the platform, cold starts can be really prohibitive. So if you break your app into thousands of little pieces, if some of those pieces haven't been used recently, they could take up to a second to become available. And if the whole point was to kind of forget about infrastructure, then suddenly have to think, well, what if these things take multiple seconds, so you can't really use it for a front-end app because a second waiting, it doesn't really matter if it's close to you. Modern platforms don't have that problem so much, but it's still something you have to think about. There are constraints, there are limitations, there are some frameworks that are making good progress on this. If you really do want to get involved in it, the serverless framework, there's a company called Begin that I quite like. But for me, I'm really looking to try and move everything to the edge. And not everything works. And also, not everything makes sense to, because you're talking about deploying your code to 300 locations, right? It doesn't make sense to deploy your entire thing 300 times, unless, again, it's just static code. Technically, Node.js can't run on any edge platform except for fly.io, which is sort of the outlier. But all the other ones, you can't run Node because Node is just too heavy. It's too tied to the idea of servers to run efficiently at the edge. So it's better now. Workers has been around for about 5 years, so lots of libraries and stuff now support it. But it's been an area of friction. But the biggest thing is, in the current situation, you really can't pretend you don't have a distributed system anymore. I mean, you never did. But it was pretty easy to pretend. When you're just running on a single server, every piece can talk to each other really quickly. When you're in a single cloud, the same sort of thing. But your users, unless they're in the same building as you, were always on the other side of the world, potentially. And so now you kind of have to, if you're going to go to this hybrid rendering model, you have to embrace this sort of stuff. You have to understand that, there's no good putting all your rendering at the edge if all the data's in Virginia. You need to understand caching and that sort of stuff. It becomes a harder problem, but you also end up with a better result. But anyway, forget about all that, because it's all going to get better, right? That's what we have right now. And I think we've made a whole lot of progress, particularly because we've emphasized two people that I think have been left out of traditional infrastructure stuff. We've emphasized the user and their experience, and the contributions of people in the organization that are not traditional back-end developers. That's what I see as great progress, right? But now I'm going to talk about where this could keep going to. I'll start in the here and now, and then I'll get off into some cool stuff. What's happening now is this term of serverless databases, right? It's a really good thing to start Googling if you're interested in this stuff. a serverless database, although it doesn't make any sense because, of course, a database needs a server, right? These are the things, these are the properties of serverless that I use, right? They scale to 0. They don't cost you if you're not using it. It's accessible to non-experts. So for a database, it has like a good admin panel or a good way to design access control lists without needing to really fully understand database permissions. With serverless databases, potentially some of them are global. Some of them are just, easier to use single databases. In fact, for about a decade, we've had NoSQL databases, which kind of, to a lesser degree, are already doing these things. But the term serverless database is generally meaning kind of more of a traditional database, something that is ACID compliant, something that's strongly consistent. These things may not mean anything to you, that's fine. But they're kind of old school databases, now new school access. Here are some. I meant to change the slide to a slide of logos, but I ran out of time. So here's a list of the names. So PlanetScale does this for MySQL. Supabase does it for Postgres. Firebase has their own thing. D1 is using SQLite. Fauna has their own thing, which is global and very cool. But I haven't heard of anyone using it really in anger in production, so I haven't tried it, but it looks cool. Upstash is one I found for Redis. Basically, whatever database tech you want to use, now you can wrap it up in the easiest API. And when I talk about easy APIs, this is the D1 API inside a worker. This is a real worker that you could deploy to 300 locations, and it would do virtually nothing. It's the hello world of database examples. That whenever you get a HTTP request, you return a JSON response, which is the number of rows in a table, right? But this env.db thing in the middle of here, which is like, that is me making a connection to a database on the other side of the world that I configured as easily as I could, right? This at the moment is specific to D1, but this API I want to try to port to all database providers that you could use within workers. It's one of my goals. To make it so that no matter where your data lives or what service you're trying to address, you just talk to it. You just say, hey, I would like this. And we figure out how to get there. Sort of brings me to the second thing. Now, this is slightly more speculative, but in my mind, these same principles, this scale to 0 accessible API, can apply to anything that an app would need to talk to. I have an example from something Cloudflare has introduced. I didn't work on this, so I don't actually know if it's available for everyone to use yet. But we announced that you can receive an email in a worker, right? Normally, workers are for HTTP traffic, so they take a request and they respond to a user. Here, it's just like, hey, I got an email on some address. You can pipe an email address to a worker. You could forward that on, you could check it for some content, you could decrypt it and put it in a database, you could do anything you want with it. But the point is, when you are now doing something as different as HTTP and email, and I'm told that wiring this up was a lot of work, the user doesn't care, right? User just I just got a fetch handler, I got an email handler, right? Like, now I can build whatever I care about because these abstractions are much higher level. So this is a trend I think will start to, I think it's already started and will continue. High-level abstractions, more accessible, more people can do this stuff. And again, there are problems, right? Because previously, in my little hybrid kind of perfect world, you had edge worker stuff that was running close to a user, and you had serverless functions that's running close to the rest of your infrastructure. And so if you're doing something that requires a back and forth to the database 4 times, that's happening from the same data center, right? That's happening in the USA. You only do one round trip, like one journey across the ocean and back. If you're talking about this magical edge worker that just talks to databases directly and everything's great, then you can have these situations where you're pinging back and forth 4 times across the ocean. And it can be just slower, right? This is the downside of taking away control, right? The upside is that it's easier for people to get started, it's easier for people to learn and get their job done. The downside is that it's pretty easy to come up with examples where things go badly. And so I know I've been talking in generalities for a while, but I'm going to get quite specific about something that I'm working on. Because this, again, speaks to this idea that these capabilities are right there, and now we're just trying to wrap them up in solutions. So this is a problem I'm facing on D1, and I was working on it last week. I haven't shown anyone this outside of the company before, so please tell me if it's really bad. But no, tell me if it's really good. Don't tell me if it's really bad. So D1 is a distributed database where you can have lots of copies of your data all around the world, but there's only one primary, right? There's only one that actually owns the data where all updates have to go to. So any change has to make its way back to here, Montreal, I guess. Let's say Montreal, right? And you can come up with a situation where you can do some code that ends up being really dangerous, right? Really bad for your system. Here my example is I'm gonna first do something to the database, which is I'm gonna update an items table. I'm gonna change the amount of inventory that's left. Then I'm gonna make an external call from my system to Stripe to say, please give me the money. And then I'm gonna update the user's balance, right? This may not be the right way to do this, but hopefully everyone can understand those things. These things need to succeed or fail together, right? Because I've only purchased something if all three of these things happen. If the user has less money, if I've taken money from Stripe, and I have reduced the inventory in the items, right? This is what database transactions are for, right? This is a little weird because a transaction usually is just a bunch of database updates. I've got database updates and JavaScript code in between, which is what the problem is. We can do multiple SQL statements really easily, but if you're trying to interplay external services and database services, it's a little tricky. And the problem is with the technology we have, we can't do transactions in the traditional sense because the code that's running on this screen is running in Zurich, but the database is in Montreal, and SQLite, the database we're building on, can only do a single transaction, a single write transaction at one time. So if we allowed you to write transactions, then any user in the world could just lock your database and it would just be unavailable. So which is way worse than, well, maybe it's not way worse, but arguably it's as bad as exposing inconsistencies. So this is my solution, which is another function, another file in the same project, in the same worker, which has a function called doCheckout. And then in my index.ts at the bottom, I call db.doCheckout. And behind the scenes, half of this code is running in Zurich and the other half is running in Montreal, which is terrifying, but solves the problem completely, right? Because then the code that's running in Montreal can be implicitly wrapped in a transaction. This can be the one way that you do transactions with D1, except for this to work, I've just designed a code API for pausing computation in one side of the world and resuming on the other side of the world, which is terrifying. So I would like to get it right, which means if any of that made sense to you at least, talk to me about it afterwards, because the implications for like debugging this stuff or logging or what happens if an exception is thrown is very difficult, but it just solves the problem so well. And I really believe in the power of these high-level APIs, rather than making you have to stop and rethink about all these sorts of things. So I'll end with basically the overarching shift in the future of hosting, the beyond serverless kind of idea. I'll give you another example. This one's a little bit less specific, but kind of maybe hits it home a little easier. Imagine that you had a worker that could do three things. The first was just render the index HTML. The second was count, and that count would make a single API call to somewhere in the world. And the third thing was validate, which would make 4 API calls. When you hit the home page, it comes straight back from Zurich, everything's great. When you try and count, it pings off, that service happens to be in the USA, no problem, you're only doing it once, no problem. Here we have the same problem as before, right? 4 requests that go all the way across the ocean and back. And what I want is for somehow computation, just like for the system to just realize that, hang on, no, for this one, the worker should be close to the service, not next to the user. Right? Similar problem to the one before. But here, I don't want the user to have to think about this stuff. What I want, and what I think will start to happen, is that the system can start to learn. It can start to observe that this situation is happening and transparently converted into this, because it knows that they're equivalent computation, but for efficiency, it's better to move it to the other side of the world. What I'm talking about here is very similar to the way V8 will optimize your code as it's running. It notices what's being hot, what's running a whole lot of time, and it inlines things, it makes things faster as it runs. The idea of doing this for infrastructure is, well, it's stunning to me, because it could completely change the level at which people interact with this. They could see something that is truly global, right? They just put functions in the ether, let alone into a cloud, that exist anywhere they need to be, they move as they need to, and I don't have to be an expert in any of it. So, to recap. This is my four-step, this is the history and future of cloud computing. First, we just got other people's computers. Then we had serverless, something that we couldn't do with just a simple server model. Then we got edge, realizing that the users are all around the world. And I think stage 4 and beyond is the idea of intelligent compute, where the system learns and adapts and optimizes. That's it. That's what I got. Thank you.
And especially, I found that very fascinating because I don't know if you know, but I organize Serverless Days Amsterdam.
Ah, there you go. Ha. Expert in the room.
Nah. All right, so again, as I said before, please put your questions into veto, and so I can veto them. Good. All right, we have a question from Luis. Glen, any insights on strategies to migrate from a traditional server architecture to this glorious future?
Yeah, that's a good question. I mean, I think particularly Cloudflare faces this a lot. Every customer kind of comes in that same approach. And so much is done, not just Cloudflare, but all of these companies, because they know that you're not talking about shifting your entire system on day one. So they make it really easy to just put some stuff across, right? So the stuff that makes the most sense to start running at the edge. So maybe you're doing some auth information at the edge, maybe you're serving some content at the edge, but you start to basically get a foot in the door with just small pieces of code. And the way, they don't have to feel like pieces of your whole system. They're kind of like optimizations. The same way that you don't necessarily consider the stuff you put on a CDN part of your system. These just become like little pieces of functionality. And that gives you a toehold, because then that means that you have the option of putting more stuff there when it makes sense. So each time you're designing something new, it's like, well, do I build it in the old system or build it in the new system? And a lot of the time, if it fits in the new system, it's a lot better there. It's often cheaper. It's certainly better for the users to be close to them. And as a result, you find yourself gradually moving things across, but only when it's justified and only as you're doing your normal job. You don't have to stop everything and lift and shift across to the cloud.
Thank you. All right, there's another question from Miro. Will edge functions have a use case in smaller applications, or do they mostly make sense in bigger enterprise apps?
It's actually, at the moment, smaller is easier because you have limitations just running on the edge. And so anything you can compartmentalize into a small thing and run at the edge is very easy to get going. One of the challenges I have, my job effectively, is to look for the places where it becomes difficult to run bigger and bigger applications. But if you scale it all the way down and think, okay, well, let's forget the entire history of cloud computing and just think, what do we got right now? If I was learning programming today, would I go to AWS and start hosting some HTML and S3 and do that stuff over there? Or would I use something like Vercel, Netlify, Cloudflare Pages, a product I used to work on, and come into it from that way? So what we're trying to design is basically this idea that you can see a thing that if you started today, you could build a whole app on it. And you can see a situation where you can put little pieces of functionality in, trying to bridge that gap and try and look for the places where it's like, well, actually, it's kind of hard to move this bit across, and it's also hard to scale from here out without going to one of the bigger clouds. So yeah, it's a work in progress, I'd say.
All right, thanks so much. Unfortunately, we don't have more time for questions, but there's more questions. Maybe you could tweet at Glen or just find him here.
Yeah, I'll be around.
Great. So we're going to have a lunch break.